Hi and welcome back. So in this video, we're going to start talking about writing linear systems as augmented matrices. So we're going to start working with what a matrix is and really look at how we can take a linear system and then write it as a matrix. So the motivation here is that we have procedures that work okay in 2 dimensions or 3 dimensions, that's with 2 variables or 3 variables, but they're going to become really complicated once we start to do higher dimensional things. So we're going to come up with a more specific procedure that works with a matrix and that is easier to do computations with, both easier by hand and easier with a computer. So we've been talking about linear systems of equations, and I just want to remind us what a linear equation is. So in general, a linear equation will have the following form. So it looks something like a1x1 plus a2x2 plus a3x3, etc., all the way to an xn, and this is going to be equal some constant b. So here the a values, a1 through an, and the b are scalars, where the a values are our coefficients. So these are just numbers that are being multiplied by the variables. Specifically, the x1 through the xn are our variables. We often write these as x and y, or x, y, and z, but once we get to higher dimensions, we often just label them all as x to make things simpler. And then we give them an index, that's that little number on the bottom, to help us keep track of which one we're talking about. So we have x sub 1 through x sub n, or x1 through xn. Then if we were to create a system of these linear equations, this would have the form with our large squiggle bracket, and then we would list out all of the equations. So I can start by just listing out the same one over and over, but we're going to need to do some things to the index, that's that little number at the bottom, to distinguish these from each other. So I'm going to give these more complicated indices, that's the index, that little number, on the coefficients just to distinguish them. So I have a11, a21, a31, all the way up until I get to whatever am1 is. So I'm just adding that number in the front to indicate which equation I'm on. So the 1, is the first equation, the 2, is the second equation, 3, third equation, etc. So the first number is which equation we're on, and the second number is which term we're on. We repeat this for the rest of the terms. I'm just going to write them here and hopefully you can see the pattern. We do the same thing on the right-hand side of the equation, so I have b1 through bm. I'm basically just adding something to all of these to really distinguish them apart. In this version of the system, we have m equations, so 1 through m of the equations, and we have n unknowns. That's how many variables there are. So rather than having all of these variables and everything written out here, we're going to transfer this to a matrix. So you can see already that now that I have more than 2 or 3 equations, it's getting really complicated, especially with so many variables. And so what we're going to do is make it into a matrix. Basically, a matrix is just a rectangular array of numbers ranged into rows and columns. So you can think of it as some rectangular object that just has numbers in it, and we refer to the rows and columns of that matrix. What we can do is write a system of equations as a matrix where each row is one equation. So the first row of the matrix will be the first equation, second row will be the second equation, etc. Let's look at what this looks like. So we take the system we started with, and first I'm going to take those equal signs and get rid of them. I'm just trying to write numbers. I don't want all of these equation things here. So instead of writing an equal sign, I'm going to put a vertical bar to distinguish one side of the equation from the other. Then I get rid of all the addition signs, and I turn this into my columns. So each term gets its own column. Then we're going to put these square brackets around this to indicate that it's a matrix. So the square brackets tell us that we have these rows and columns and that we're looking at a matrix and not just some random assortment of things. Then since each column has the same x in it, so the first column is x1, the second one is x2, etc., we're going to get rid of the x's. We're going to get rid of the variables altogether. And so now I'm just left with the coefficients. So I have all of the coefficients listed, and then I have the vertical line and then our b values on the right-hand side. Because the matrix with all of the a's contains the coefficients, we call this the coefficient matrix, And then when we have that vertical line with the additional part added on, we call this the augmented matrix because we basically added something to the coefficient matrix. We'll talk more about matrix properties later, but something that is good to know for now is that we usually refer to the rows with an R and then an index. So the first row is R1, the second row is R2, the third row is R3, all the way until we get to the mth row, so Rm. So all of this sounds a little complicated, I know, but once you actually just start with the system and have to write it as a matrix, it's really not that bad. For our first example, let's write the system 3x plus y equals 10 and negative 2y equals x plus 1 as an augmented matrix. So in the matrix, the variables are on the left-hand side and the constant is on the right-hand side. So we're going to rewrite our equations to match. The first equation is good, it has the x and the y on the left, but it needs the second one changed. So I'm going to move the x to the left-hand side, and I'm left with negative x minus 2y equals 1. Now, I want to determine all of the coefficients so that I can write them in the matrix. So what I'm going to do to help me out is just take a 1 and write it in front of the variables that don't have a value. So I really have 3x plus 1y equals 10, and negative 1x plus a negative 2y equals 1. So I've just isolated those coefficients there to make them really visible, and now we just need to translate them to the matrix. So I'm just going to read them across. So the first equation is a 3, 1, and then a 10, and the second equation is a negative 1, negative 2, and a 1. And there we go. That's the whole thing. So we took the system, put the x and the y's on one side, the constants on the other, and then we just wrote down the coefficients properly. However, I want to point out one more thing before we move on. So augmented matrices, there isn't always just one solution. So depending on how we rewrote things in the very beginning, your matrix might look a little different. So instead of the steps we took, let's imagine that we had rewritten things a little differently. And let's say we had ended up with x plus 2y equals negative 1. Then when we went to write our coefficients, we would have 1x plus 2y equals negative 1. And this would have signs swapped from what we just did. So instead we would have 3, 1, 10, that would be the same, but our second row would be 1, 2, negative 1. So basically just by moving things a little differently at the beginning, we got a slightly different answer. I say this just to make sure that you know that depending on how you rewrite the equations, your matrix might look different. So if you're checking your answers with somebody, what you do might look slightly different. Let's try this on one more example. Let's write the system 3x minus 2y plus 5z equals 0, y minus z equals 8, and negative 4x minus 1/2 z equals 3 as an augmented matrix. So I've given this one to you in a way where it does not need any rewriting. It has all of the variables on the left-hand side of the equation. So now we just need to identify the coefficients, those numbers in front of the variables, in order to write them in the matrix. So the first equation isn't too bad. I see that we have a 3, a negative 2, and a 5. For the second equation, I'm noticing that we actually have a 1y minus 1z. It's also good to note here that we have a 0x, so there aren't any x's. Then for the last equation, we have a negative 4 on the x, we actually have a 0 on the y, and then we have a negative 1/2 on the z. So these numbers we now write in our matrix. So we read them across. We have 3, negative 2, 5, and then our 0. We have 0, 1, negative 1, then our 8, and we have negative 4, 0, negative 1/2, and 3. And you should see that these coefficients in this matrix match up with the equations we started with. So I know it can be a lot to see the matrices for the first time, it's a lot to write it out in general, but once it actually comes down to doing it, it hopefully isn't too bad and you can see the patterns that are going on. That's it for this video. Thanks so much for watching, and I will talk to you in the next one.